I was actually thinking, so things that we are going to get to, we've already talked about some of the things with the derivative. The main thing that we focus on in derivative is you have some curvy thing. And when you have a curvy thing, you have an infinite amount of lines that are tangent to the curvy thing. If you remember back from geometry, a tangent line is something that will touch a graph once. And then you're like, does that relate to the tangent of like when you're doing sine, cosine tangent? And the answer is yes. But, so we did, this was the assignment I gave you, right? 4.3. All right, so find the derivative of the following. So what's the derivative of y equals 4? 0, yeah. So the derivative of just a number is 0. And then derivative of this would be like 90x to the 8th, because you bring the 9 down front, multiply by the 10, lower the exponent, minus 25x to the 4th, plus 21x to the 2nd, plus 5. The x goes away on this one because this is to the 1st. You bring the 1 down front, then it becomes to the 0. X to the 0 is 1. And then the derivative of -6 is 0, so you don't even have to list it. And then you have these that have the negative exponents. So the negative exponent is going to come down front, but you're going to subtract 1 from the negative exponent. I didn't get you.
You did.
Oh, I got you again. Best day ever. So you get the -5x that comes down front. You subtract 1 from -5, so you get to -6, and then you get -8x to the -9, and then minus 3x. The x goes away because it becomes x to the 0, x to the 0 is 1, and then the derivative of 10 is 0. Now, if you got to this point, you're great. If it was on a multiple choice, this would actually be the answer. So I moved the negative exponents to a new location. I moved them down, so they became positive exponents. Okay, number 7 is goofy. Agree? You're like, I have the third root of x. You didn't tell us how to do derivatives of radicals. Okay, you're right. I'm wrong, but I'm married. I'm used to being wrong. So I'm going to clean this up first before I do the derivative. So I'm going to get 3x to the -4. Do you feel comfortable why that is x to the -4? Is anyone not sure? That's not the derivative. That's just rewriting it so I don't have the letter in the denominator. So I move whatever's in the denominator, I move it up to the numerator. I only have a 1 in the denominator, so I don't have to keep it there. And then it becomes a negative exponent because I moved it up. And then the next one, I'm going to get plus 2x to the -5. So again, I'm moving it up to the numerator. It becomes a negative exponent. Okay. So I just want to make sure you're good with those first 2 iterations of this problem. Anyone not quite sure? Okay. So then I have plus 5. And a few things I have to know. I have to know that that's x to the first. I can write this as an exponent. So this is going to become x to the 1/3 power. Okay, that gets a little goofy. Okay, so that takes you back to maybe from algebra 2. You have to remember how to turn a radical into an exponent or an exponent into a radical. So that's basically the thing. So that's definitely key on this problem. Now we're ready to do the derivative. So f prime, remember I don't have to do that anything. So I'm going to bring the -4 down. So I get a -12x. I'm going to subtract 1 from that. So I get to the -5. This one I'll bring the -5 down, multiplies with the 2. Subtract 1 from that. And then I have plus, bring the 1/3 down front. So this becomes 5/3 x. If I subtract 1 from this, 1 is the same thing as -3/3. So this becomes the -2/3 power. Ooh, that one, whole lot of, hey, good to see you. Whole lot of like prior knowledge, back in the day, math classes of problems that you might have skipped. But it's there. That's the nice thing is, when we do the stuff as a group, we get the opportunity to build off each other's knowledge to hopefully help you out. So now we can clean this up. Okay, so this is going to become this. This next one's going to become this. And then this one becomes now you could, if you wanted to, you could take the exponent that's a fraction and you could put it back in radical form. I would tell you in future calculus math courses that might be something that might be done sometimes, but not always. But all in all, this is the derivative of that original one. Whew! Anyone else need an app? All right, good stuff. All right, how do we feel? Do we feel okay about those first 4 problems? Okay, it's just kind of guided. The nice thing is, between you and the people around you, hopefully you have enough knowledge of, oh, I can attribute this, so-and-so can do this, and we can get through these types of problems. And that's the blessing of doing these. Okay. May I move this? We good? All right. Number 8. You're given this function, y equals 4x squared plus 3x, so it's a parabola that opens upward. Great. Find the slope of the tangent to the curve at x equals 2. And then it says, find the equation of the tangent line that runs through x equals 2. Okay, I did not teach that yesterday, and it's okay that we're going over it today. So let's take care of A first. I want to find the derivative of our function. That'll allow me to figure out what the tangent slope is exactly at that point. So I'm going to go y prime equals 8x plus 3. I just did the derivative. And then I'm going to figure out, this is going to get me the tangent slope at this point. I'm going to take this, I'm going to plug it in. I'm going to get 8 times 2 plus 3, which is 16 plus 3. So this is 19. This is my slope. Okay, let's pause there for a minute. Okay, our original function is a parabola that opens up. Can you envision the parabola opens up? If I went exactly to 2 in the x direction, and I went up to my graph at exactly that instantaneous point at 2, there is a tangent line that would go through and kiss the parabola once, and that would have a slope of 19. And I'm going to show what all of this looks like here in a second. So let me go do this. I'm going to jump over to Desmos. So let me just graph what the equation looks like. Y equals 4x squared plus 3x. Okay. Let's make this a little darker. Okay. So okay. This is our original graph. This is the parabola that works with. Okay, so if I counted over 1, 2, and I drew a line straight up here, and I found where this kisses, okay, so right here at my fingertip, let me see if I can do this. How can I do this? I can do it this way. Annotate. At 2. So this point right here, okay, there is a straight line that's going to come straight down like this, and it's going to go touch that point right there, that blue point. This line here is going to have us a slope. What did I say the slope was? I just solved it. 19. So this has a slope of 19 over 1. Okay, right at that point. If I came down here, the slope's different. If I went above it, the slope's a little different. If I came over onto the left side, the slope is negative. But this is like a straight line that is a tangent line to our graph. And the definition of a tangent line is, if this was the line, and I have a point right here on a graph, this is the tangent. This tangent line can change its what it is based on how the graph grows. Okay? I hope that somewhat kind of sort of makes sense, where we can clear it up a little bit. So let me go away from this. Let me go to this, and I realize that's going to be stuck there, but we're okay. So now it says find the equation of the tangent line through this. So I'm going to take this point here, and this is going to go back into the original. Okay, so this is going to find me the point 2 comma something. I'm going to plug 2 in here and here. So I'm going to get 2 squared plus 3 times 2. So that's 4 times 4 plus 6. So that's 16 plus 6. So that's 22. Okay, so what this finds me, this is the point 2 comma 22. Which if I go back to my graph, hopefully it hasn't moved. Nope, I didn't mean to go to Firefox, sorry. 2 comma 22 is this point right here. So this point right here is the point 2 comma 22. So at the point 2 comma 22, our tangent line will have a slope of 19 or 19 over 1. So then I can find the equation to our tangent line at exactly that point. So if I go back here, and there's a lot to this problem, I get it. So this is going to take you back to, do you remember the fun days of Algebra 1? There was an equation that they showed you for about 1/30th of a second. And this was called point slope. Okay? So if you remember, you guys remember y equals mx plus b. Agree? And then we taught you another way to deal with it, where you might have ax plus by equals c. And we might have taught you something called the cover method in order to graph that, where it showed you where it crossed the x and y axis. Well, this equation is going to go with, it's going to go with our tangent line. So what I'm going to do is my point that I found from my original, I'm going to call this x1, I'm going to call this y1. So I'm going to get y minus 22 is equal to, our slope we said was 19 or 19 over 1, and then I have x minus 2. Okay. The nice thing is we're done with the problem, but I want to show you what this, pardon me. All right, so I'm going to jump back onto Desmos. Y minus 22 equals slope of 19, x minus 2. Okay. So I'm going to get rid of my annotations. Okay. So at 2 comma 22, the slope at that exact point, the blue line is called the tangent line. If we zoomed in on that, it doesn't really look like the tangent line. It's a tangent line as it sits because it's let's do this, 0.2 comma 22. we zoom in like a jillion times. That, don't put that. Blue, okay. At some point here, it's going to separate. We're going to see the red and the blue. I can't even get to it. Yeesh. All right, well, let's just go back home. All right, so you see the blue line and the red. And as I come up here, you see how the red and blue separate from each other? That's what I was trying to show as I zoomed in, but I clearly failed at it. So again, this is the equation tangent. Now, again, if I came down here, I'm going to get a different equation and a different slope. If I come way up here, I'm going to get a different equation, different slope. Come over here, I get a different equation, different slope. The slope on the left side is going to be negative because it's downward falling. Oh my goodness. Okay. That's a lot of meat and potatoes that goes with a problem. And I get it. So I want us to kind of like, let's walk through a problem that's not given to you. Let's just make something up. Let's say we have so this as a graph looks something like this. Okay? And in theory, there's an infinite amount of lines that are tangent to this, what we're doing. So each one of these little tiny lines here represents a different tangent line to this graph. So if we wanted to say, we want to figure out what the equation is, oops, I want to figure out what the equation is at 1. Okay? So the first thing I'm going to do is I'm going to do the derivative. I think you guys are okay with this. So that's my derivative. If I take this and plug that 1 in here and here, and that's going to give me 3 plus 14 plus 4. So that's going to give me 21. So this finds me the slope at that exact point on our graph. Okay, so that might be like somewhere right here. Okay, I'm just making that up. I don't know what the graph looks like. I didn't graph it exactly. If I want to find my point, I'm going to take this and I'm going to plug it into the x's up here. So I'm going to get 1 to the third plus 7 times 1 to the second plus 4 times 1 plus 5, which is 1 plus 7 plus 4 plus 5, 8, 12, 17. So that means the point 1 comma 17 is my x1 and my y1. Okay, so let me pause there. I'm not done with the equation yet. So the first step to doing these, find the derivative. Second step is take the point that's given, the x value that's given, find the slope from the derivative. Then find the actual point itself from the original x value that's given. So that point exists. So if this point right here was what we were talking about, has a slope of 21, this would be the point 1 comma 17 that would exist on our graph. Then we can go back and we can use point slope. And again, Algebra 1 teachers don't do a great job using point slope because by the time you start graphing every type of line, they're like, yeah, this is an afterthought. So these values plug in and this value plugs in, and it's simple because you can just leave it as is. So this is the linear equation that is tangent to our original graph at the point 1 comma 17 in which it would have a slope at that exact place of 21. Is this boggling anybody? Is it okay? It's kind of a step-by-step procedure. I hope that when you work on it together, you'll be able to figure out how it works. But there's kind of a lot to it when you look at it going, you filled the whole board with one problem. It's like, yes, I did. All right. Let's go to number 9. Okay. Talk to me, friends. What is the first thing I should do on number 9? Do what? Find the derivative. So let's get the derivative first. So I'm going to get y prime equals 3x squared minus 6x. And that's done. What can I find from the derivative if I plug x equals 1 in? Find the slope. So if I take the given point, x equals 1, and I plug it in here, that's going to get me my slope. So I'm going to get 3 times 1 squared minus 6 times 1, which is going to give me 3 minus 6, which gives me negative 3. So I get a slope of negative 3 of that. So again, 3x to the third is kind of an equation that looks like this. And then the ends go opposites. There's some wiggle room in there. So what's the next step after I have found the slope? Yeah, plug this into this, and that's going to get me my point. So it's going to be 1 comma something. So I'm going to go 1 to the third minus 3 times 1 to the second plus 5, which is 1 minus 3 plus 5 if I do the math, which is negative 2 plus 5, which is 3. So that means at 1 comma 3, this is my x1 and my y1. And then again, you go back to algebra 1, you're like y minus y1 equals m times x minus x1. Excuse me, I'm going to choke on something. No, why'd you go down? So if I plug that in, I'm going to get y minus 3 equals negative 3 x minus 1. So this is the linear equation. This is the linear equation that is tangent to our graph at x equals 1 that takes place. Oh my goodness gracious. All right. Number 10. It's like, dude, you had me kind of, sort of, and now you change things. Determine all the x values where the graph of f at x has horizontal tangents, so where the derivative is equal to 0 of that. What this means is you have a graph that does this type of stuff, right? So you're looking where the peaks and the valleys are. That's the turning point. The turning point are the local maxes and the local mins. The local max is where it goes up and then down. You have the max. Local min is where it goes down to go up. Local min. So max, min. Okay? So we want to figure out where our parabola would have this take place. Okay. So what I'm going to do, I'm going to find the derivative first. Oops. Okay. So now we want to figure out is where our derivative has a slope of 0. So I'm going to set this equal to 0. I'm going to factor a 4 out and an x squared. And that's going to leave me x minus 3. If I set this equal to 0, I get 4x squared equals 0. So that means x equals 0 and x minus 3 equals 0. So x equals 3. So at 0 and at 3, we would have a tangent line that the slope would be equal to 0. And you ready for the last problem of the day? Okay. Write the equation of the tangent line to the curve. So now we went back to what we were doing. We're talking about x equals 4. All right. So the first thing I'm going to do is I'm going to rewrite this equation to where I do not have a radical. So if I have a square root's the same thing as the 1/2 power. I'm going to find the derivative. So y prime, derivative of 5 is 0. Bring the half down front. So -2 times half is -1. X, I'm going to subtract 1 from that, which is 2 over 2 to the -1/2, which our derivative cleaned up is -1 over x to the 1/2 power. That's the derivative. Ooh. I don't know what it did. No, don't go to help. I don't want help. I don't want help. I don't need help. So I'm going to take this 4. I'm going to plug it in right here. So I get -1, 4 to the 1/2. The 1/2 power is the square root. What's the square root of 4? 2. So I get 1 over 2. -1 over 2. So my slope is -1 over 2. And then I'm going to take this 4. I'm going to plug it in here, and that's going to get me my point, 4 comma. So I'm going to get 5 minus 2 square root 4. Square root 4, you just told me, is 2. So I get -2 times 2. So it's 5 minus 4, which is 1. This is my x1. This is my y1. Plug in a point slope. Okay, so I'm going to get y minus 1 equals -1/2 x minus 4. And that, my friends, is how we do that. Heavy? Yeah, these can be a little bit rambunctious. So we're going to work on this review, but I'm not the only ones I'm going to tag for us to work on tomorrow. So tomorrow's Wednesday, right? So I would like you to try 17 and 18. It's done the exact same way we've just been doing these. See if you can figure those out. We'll do more of the review on Wednesday. On Thursday, we'll have something on Schoology for you guys to knock out of the park. Everyone's good? Anyone going to cry themselves to sleep tonight?